Hello again, YouTube. And no, not deja vu. This is the same plug we looked at last time. And last time we fixed it by taking it apart and not doing anything, and the relay we determined was sticky. But it started working again, so it's now failing again, the sticky relay. So instead of having a relay, my plan is to take it out and replace it with a solid state relay. But I don't have one, so I'm going to have to make one. This is us back apart again, and this is the relay that has gone bad, so it keeps sticking. So we want to remove this relay and replace it. Now, what we got, these two pins here are going to be the coil of the relay, and between there and there, yeah, between there and there is the switched output of the relay. So what I want is a thyristor across there, optocouple across there, and I think the best way to describe what I want to do is with a picture. So let me get my pen. What we need is a circuit something like this. This is our old relay, and in place of it, we take this out. So on the coil side, we just fit a resistor and an LED. So we need to work at the value of that resistor by measuring the voltage across the coil. And on the switch side, there's a switch again, that's not going to be there. The switch is now the thyristor, so the thyristor sits between the switch side. Then we have an optocouple, so the receiver side of the optocouple. It's going to go to the gate pin, another suitable size resistor back here. So this obviously is AC, so this is going to be live or neutral, 240 volts. That'll drive the gate, and then boom, shunt it through. That's the idea. We might need another resistor this side up to here, just to up this side, just to bias this a little bit. Might need to play a little bit. Have to work the values out, but that's the idea generally. But we'll see. So first job, first job we've got to measure the voltage across the coil. So you can work out that value resistor, and then you'll remove the relay. We'll do that now. And now we have a dangerous live ball of death hanging in the air because it's all powered and live, and that's true because there's a LED lit. And I've got the app open here, so I can turn it on and off. You can hear it tick, and that's the relay now working because it's decided to work today, but it doesn't always work. There's a blue light to turn it off. So we're going to turn it on, measure the voltage across the coil, which is them two pins. So I shall do that now with my probes of death, and that's on DC. Can I do this one-handed? Because that's always a great idea, doing it live and one-handed. Oh. No. I need 2 hands for this. I'm a professional. I'm not professional. There you go, 5 volts. Look at that, 4.9. 5 volts. See, I do know what I'm doing. Off. Right. Current for a 5 volt LED. That'll probably be about, I don't know, let's try 500 ohms. Oh, I've got a 120 ohm resistor. That would do. Let's try that. So first part of the mod is done. The relay is out, and the optocoupler is in. Now, yeah, don't take too much into the soldering. This is all just an experiment. I haven't got the right components yet, just to show us if this even works. So there's our optocoupler in, and I'm measuring the output of the optocoupler on the meter. And if I turn on the switch, you'll see the light go blue. You go blue light on, and the ohms has gone up to 18k-ish, but you're measuring through a transistor, so that is at least changing, so that's doing something good. So that is good. Turn it off, and it goes over circuit, so that's working. So what you do is fit the output stage, so the thyristor side of things. So let me get the floor because I haven't planned any of this. So we've got this part of the circuit done. We just need to add the thyristor and the resistor, which 20k. Yeah, shouldn't have to be too much, should it? You don't have to play around with values. Might just add like a 10k in or something just to see what happens, because 10k across 240 volts will be fine. So we'll add a 10k in and see what happens. And there it is, isn't it? A work of art. Now, obviously, this complies to all soldering requirements, ISO standards, and electrical safety standards. So, yeah, look at that. So the optocoupler is flying around in mid-air. Got the resistor going across to the main side, and the thyristor stuck in the middle there. And look at that electrical separation there. Shall we zoom in on that? Look at the electrical separation on that. Boom. There we go. I know you're thinking that's a work of art. So yeah, the gate pin's bent underneath. Goes over to the octocouple. Octocouple output over there to the live. Well, I've got a live output. Maybe that's a mistake. Should be on that pin, shouldn't it? Because that's going to be... it might work though, because of course it'll be going through a load. We'll try it, and if it doesn't work, we'll move over to that side. Because, you know, this is a professional operation that we run here. Right, let me plug it in. I'll plug it in on camera, because you never know, it might blow up, and that'd be pretty cool, wouldn't it? So next shot will be plugging in and then turning on. Look at that for a smart plug. Can you imagine that poking out your wall? That'd be brilliant. Right, so let's apply power, and we'll see if there's any small explosions. There is no small explosions. We are onto a winner. Right, I am not going to push the button. I am going to wait for this to get an internet connection and use the app. Because if I push the button with my finger, I think I would die. So where's the app? There's the app. It's the iWii Link Soft app. And I think it's connected. And right, here we go. I'll get the app into shot. There's the app. Ready. Ah. The light is not on. Bugger. Just see if it's... Nope. Right. Turn it off. It may be because that resistor is in the wrong place. Or it may be because I've just messed it up and this doesn't work at all. So I'm going to turn the power off, and I'm going to move that resistor from the output side of the pin to the input side of the pin. And then hopefully that will work. If it doesn't, then I've really screwed this up. Right, resistor moved. And clear. Contact. Oh, that's annoying. Got a flickery light. What? Oh, that's really annoying. Why is that light flickering? Right, okay. That looks like that's only single phase rectified. That's that hasn't improved the light situation. I've broken it. I've made it worse. There we go. Oh, you can see the light is flickering. Yeah. So you can't see it on camera, but that light is flickering like mad. So it's got a 50 hertz ripple on it, and the switch doesn't work. It's always on. Huh. That's annoying. Well, it hasn't blown up, so that at least the fundamentals is right. Let me think. So I've added in a pull down resistor here onto the load side to try and pull the gate off, because I think maybe what's happening is the gate's always on and floating around or something. So it's a potential divider, pull the gate closed, turn the gate on. It may work. It might work, it might not, I don't know, but yeah, maybe I should go on that side, into that pin, then that pin would then turn it off, wouldn't it? That might be a better idea. Yeah, I'll move on to that one. I'll do that. Sod it. I'll try it as it is with it on, you know, the two resistors. That's just because I'm intrigued. So on. Different flashing pattern. You can see the flashing pattern in the camera now. Warning, strobing. So it's doing something. That is really incredibly annoying. Ah. If I turn it on, there is no flashing. I mean, you're seeing that on the camera, but I'm not seeing that in real life. And then off. Flashing. Oh, we're nearly getting there. I think it's just tweaked the resistor values. I'll move the resistor over and see what the effect that has. Right, I've moved this off resistor, or the bias off resistor, to this side of the transistor that then drives the gate. So this is pulling the gate directly down on resistor on the optocouple side. If you know what I'm saying. Good. Right, power up. Again, power being applied live. Oh, now we've got noises. It doesn't like that at all. That's even worse. It's making the bulb flash. Why is this something so simple not working? Right. Happy bulb, noisy bulb. That's actually better in its other state. How annoying. How annoying. That should work, shouldn't it? I mean, look at it. You can see why it should work, can't you? It's a work of art. Right. I'm going to have to go and have a think about it. This is taking too long, and I'm annoyed, and I'm late, and I'm hot because it's really hot today. Yeah. I'll leave it there for now, and I'm going to have a think about why it doesn't work. If you have any thoughts, questions, comments, leave a comment, because that means that someone watches this crap. And I'll see you there. But, I mean, as a smart plug, look at that. That's pretty cool, isn't it? I mean, that'll keep the children away. But for now, I'll see you later. Bye for now.